Good day, everyone. Today, we're diving deep into the fascinating world of data analytics in the Indian Premier League, IPL. The IPL isn't just about thrilling cricket matches, it's also a game of numbers, strategy, and insights. From player performance evaluation and team selection to match predictions and auction strategies, data analytics plays a crucial role in shaping the success of teams. We'll explore how advanced statistics, machine learning models, and real-time data tracking influence decision-making on and off the field. Whether it's uncovering batting patterns, optimizing bowling lineups, or predicting match outcomes, analytics is revolutionizing the sport like never before. Stay tuned as we break it all down with real-world examples and insights. This session will cover various aspects of IPL analytics, starting with an introduction to the league and the growing role of data in sports. We will explore how data-driven decision-making has evolved in IPL and its impact on teams, players, and strategies. The discussion will also highlight key challenges faced in IPL and how data analytics has contributed to solving them effectively. A significant focus will be on the role of analytics in player auctions, helping franchises make informed investment decisions. We will examine how successful teams have leveraged data analytics to enhance performance and gain a competitive edge. The session will also introduce tools and techniques used in IPL analytics, including data collection, processing, and machine learning applications. Furthermore, we will discuss data visualization techniques that help teams and analysts interpret complex datasets for strategic insights. Key aspects of IPL data analytics, including use cases and clustering methodologies, will also be covered in detail. The presentation will conclude with an analysis of clustering player attributes and how franchises utilize this information for team composition. Through this session, we aim to understand the growing significance of data analytics in modern sports management. Let's begin our exploration of how data is reshaping IPL and revolutionizing cricket. This section continues our discussion on IPL data analytics, focusing on advanced methodologies and future trends. We begin with creating player statistics from raw data, an essential step in performance analysis. Next, we explore how clustering algorithms are applied to player data to derive meaningful insights. A use case conclusion will summarize the key takeaways from these analytical techniques. We then discuss the future of data analytics in IPL, highlighting emerging trends and innovations. The role of data analytics in umpiring and fair play will be examined, showing its impact on decision-making accuracy. Biomechanics and wearable technology will be explored for their contributions to player performance and injury prevention. We will analyze the use of data analytics in cricket betting, addressing its impact on the sport. The integration of blockchain technology in IPL data analytics will be discussed, emphasizing transparency and data security. Finally, we will conclude with key insights, reinforcing how data analytics is transforming IPL and modern cricket. What is IPL? The Indian Premier League or IPL is a T20 cricket league founded in 2008 by the BCCI. It features teams representing different states in India and includes both Indian and international players. Over the years, IPL has grown into one of the most popular and lucrative leagues globally, attracting top players from across the world. The league was conceptualized by the BCCI in 2007 and has since revolutionized cricket with its fast-paced format and entertainment value. Usage of sports analytics in IPL. Team strategy. Data science plays a crucial role in formulating strategies, player selection, and real-time decision-making. Player performance. Analytics provide deep insights into player skills, helping teams make informed decisions. Predictive analytics. Historical match data is used to predict match outcomes and optimize game strategies. Fan experience. Personalized content and immersive experiences enhance audience engagement. VR and AI, virtual and augmented reality, powered by AI, enhance fan interaction and experiences. Injury prevention. Predictive analytics help in reducing the risk of injuries by analyzing player fitness. Emerging technologies, AI and machine learning provide detailed insights into player performance. Data privacy. Given the vast data collected, ensuring security and privacy remains a top priority. This highlights how data analytics is deeply embedded in IPL, impacting gameplay, team strategies, and fan engagement. Scope for growth of sports analytics. The sports analytics market is projected to witness significant growth, reaching billions of dollars by the end of the decade. Market expansion. The increasing adoption of data-driven strategies in sports is fueling industry growth. Technological integration. Advanced technologies like AI, machine learning, and wearable devices are revolutionizing player performance analysis and fan engagement. Regional growth. The Asia-Pacific region is expected to experience rapid expansion due to growing sports popularity and increasing reliance on data analytics. Application segments. On-field and off-field analytics are key growth areas, with performance analytics seeing major advancements. Industry opportunities. Emerging trends such as cloud solutions, sports betting, and fantasy sports present lucrative business opportunities. The market was valued at $2.45 billion in 2021, with a projected CAGR of 27.3%, indicating a robust expansion rate. North America accounted for 43.4% of the global sports analytics market in 2021, highlighting its dominance in this sector. Big data adoption is a key driver of market growth, enabling better decision-making and strategy optimization. As technology advances, sports analytics will continue to transform how teams, players, and organizations operate, making data a crucial asset in competitive sports. The rise of data-driven IPL. Over the years, IPL has evolved significantly in terms of data analytics and technology integration. Early days between 2008 and 2015, data analytics was primarily limited to traditional cricket statistics such as batting statistics, runs, strike rate, and batting average. Bowling statistics, wickets, economy rate, and bowling average. Win-loss records, team standings, and match results. Data collection was mostly manual or semi-automated during this period. Latest days between 2019 and 2024, the use of advanced cricket statistics has transformed IPL strategies. Analytics is now used for ball tracking, DRS or decision review system, and shot analysis. Players use smart sensors to track fitness, fatigue, and performance. Teams rely on live match data to adjust strategies in real time. Predictive models help forecast player performance and match outcomes. Franchises use sentiment analytics and engagement metrics to enhance fan experiences. Overall, the shift from basic to advanced data analytics has revolutionized IPL, making it a highly strategic and data-driven league. Problems in IPL and how data analytics helped solve them. IPL teams face several strategic and operational challenges, but data analytics has provided effective solutions. Challenge: injury management and player workload. Solution: wearable sensors, AI models, and GPS tracking help monitor workload and predict injury risks. Example: Rajasthan Royals use biomechanics and GPS tracking for injury prevention. Challenge: inefficient team selection in auctions. Solution: predictive analytics assess player consistency, impact, and role fit. Example: KKR identified key players like Andre Russell based on performance data. Challenge: death over bowling strategy. Solution: economy rate analysis under pressure helps teams choose the best death over bowlers. Example: Mumbai Indians optimized Jasprit Bumrah's role using analytics. Challenge: opponent strategy and match simulations. Solution: machine learning models analyze opposition weaknesses and predict match scenarios. Example: CSK adapts strategies for spin-friendly pitches using AI-driven insights. Challenge: fan engagement and viewer retention. Solution: social media analytics track fan sentiment and optimize marketing content. Example: KKR uses real-time fan interaction data to enhance engagement strategies. Overall, data analytics plays a crucial role in addressing key challenges in IPL, improving player performance, match strategies, and fan experiences. Usage of data analytics in IPL auctions. Data analytics plays a critical role in IPL auctions, enabling teams to make strategic and data-driven decisions. Teams use analytics to evaluate player performance, predict future potential, and optimize budget allocation. Key areas where data analytics is applied in auctions. Budget optimization and smart bidding ensures teams bid strategically to maximize value while staying within budget. Opposition squad and auction trends analysis helps teams study rival squads, past auction trends, and market dynamics. Player performance analysis, teams analyze data from T20 leagues, international matches, and domestic tournaments to assess player consistency. Machine learning models help identify the best combination of power hitters, finishers, all-rounders, and bowlers based on past performances and predictive insights. Overall, data analytics leads to smarter bidding, a well-balanced squad, and improved on-field performance, giving teams a competitive edge in the IPL. How champion teams use data analytics. Data analytics has played a key role in the success of IPL champion teams like Mumbai Indians and Kolkata Knight Riders. Mumbai Indians, one of the most successful franchises, leveraging data analytics for a competitive edge, uses a software called Cricket 21, which analyzes data from video footage, player statistics, and performance metrics. Helps identify areas for improvement and make strategic, data-based decisions. Example, used analytics to determine the best batting and bowling combinations based on pitch conditions and opposition teams. Kolkata Knight Riders or KKR has been using data analytics for player recruitment strategies. Utilizes a software called Moneyball, which applies statistical analysis to identify undervalued players for cost-effective signings. This strategy has allowed KKR to build a strong team within a limited budget and remain competitive against bigger teams. Overall, these teams showcase how data analytics helps in decision-making, improving team performance, and maintaining dominance in the IPL. Tools and techniques used in IPL data analytics. IPL teams leverage various tools and techniques to analyze performance, improve strategies, and gain a competitive edge. Data collection and storage. Technologies like Hawkeye track ball trajectory, player movements, and decision-making. SpiderCam captures in-match visuals to analyze player positioning. Wearable sensors monitor player fitness and workload. Opta and CricViz provide detailed player and match statistics. Data processing and management. SQL or NoSQL databases store structured and unstructured cricket data. Apache Spark and Hadoop manage and process large-scale cricket data in real time. Performance and strategy analysis. Win probability models are used in real-time match analysis. Opponent analysis helps understand strengths and weaknesses of competing teams. Machine learning and predictive analytics. Regression models predict scores, player performance, and match outcomes. Clustering models group players based on skills and past performance. Deep learning is used for advanced game strategy predictions. Natural language processing or NLP analyzes social media sentiment about teams and players. Data visualization and BI tools. Tableau and Power BI are used to visualize player performance and trends. Python, particularly package Matplotlib, Seaborn, and other languages are used for deeper statistical analysis and custom visualizations. Overall, these advanced tools and techniques help teams make data-driven decisions, optimize performance, and enhance fan engagement in the IPL. Data collection. Introduction to CricViz. CricViz is an advanced cricket analytics platform providing deep insights into player performance, match strategies, and team dynamics. It gathers real-time data to enhance decision-making for teams, broadcasters, and analysts. Types of data collected. Fast path data provides immediate match data collection for crucial moments. Collected by expert analysts present at the ground. Powers live scorecards and media analytics. Event data tracks detailed statistics for each ball, including delivery type, shot selection, and fielding plays. Enables real-time match context analysis. Supports CricViz enhanced match centers and predictive models. Performance data offers comprehensive batting, bowling, and fielding analysis. Assists in team and individual player evaluation. Provides access to CricViz's advanced performance tools and data science models. Why is this important? IPL teams leverage CricViz to refine strategies, player selection, and in-match decision-making. Data-driven insights help coaches and analysts optimize performance and gain a competitive edge. Data processing. Why SQL for IPL analytics? SQL is an essential tool for storing, analyzing, and querying IPL-related structured data. Helps teams and analysts efficiently track matches, player performance, and team metrics over time. Key SQL applications in IPL data processing. Time series analysis. SQL with Group BY is used to track IPL trends over seasons. Example, identifying how a team's win rate has changed over the years. Joins for insights. Complex joins help analyze team versus team records, player versus player statistics, and match outcomes. Example, finding how a specific bowler has performed against a particular batsman across IPL seasons. Stored procedures and views. Automates reports and creates data views for dashboard integrations. Example, auto-generating a weekly performance summary for team management. Indexing for faster queries. Indexing on key columns like player ID, match ID, and team ID improves database performance. Example, instant retrieval of a player's strike rate across multiple IPL seasons. Why is this important? Efficient data processing allows IPL teams to make strategic decisions faster. Enhances real-time match analysis and predictive modeling. Introduction to machine learning in IPL analytics. Machine learning or ML plays a crucial role in IPL by analyzing vast amounts of match data. Clustering, an unsupervised ML technique, helps group similar players, teams, and matches based on different attributes. How clustering is used in IPL analytics. Player segmentation. Groups players based on their batting or bowling styles and performances. Example, identifying power hitters versus anchor batsmen based on their strike rates. Team performance clustering. Identifies teams with similar match outcomes based on win percentage, run rate, or player combinations. Example, teams with strong depth over specialists can be clustered together. Match outcome prediction. Matches are clustered based on venue, pitch conditions, and toss results. Example, matches played in Chennai's spin-friendly pitch are analyzed separately from high-scoring Mumbai grounds. Fan engagement clustering. Social media analytics use clustering to analyze fan reactions for IPL teams and players. Example, identifying which teams generate the most positive buzz online. Why is this important? Clustering helps teams and analysts predict match outcomes, optimize squad selection, and improve fan engagement strategies. IPL franchises use these insights to refine their game plans and marketing approaches. Introduction to data visualization in IPL analytics. IPL generates vast amounts of data on player performances, team strategies, and fan engagement. Power BI and other visualization tools help teams analyze and interpret this data through interactive dashboards. Key dashboards used in IPL analytics. Player performance dashboard. Tracks batting and bowling stats such as runs, strike rates, wickets, and economy rates. Example, identifying top performers like orange cap or highest run scorer and purple cap or highest wicket taker. Team performance analysis. Evaluates team strengths and weaknesses based on match statistics. Example, analyzing KKR win percentage when chasing versus batting first. Match outcome prediction dashboard. Uses past match data, toss results, and venue conditions to predict outcomes. Example, predicting win probability for teams based on head-to-head records at a specific venue. Fan engagement and social media analysis. Monitors social media trends and fan sentiments related to IPL teams and players. Example, measuring Virat Kohli's social media mentions during the tournament. Ticket sales and revenue analytics. Tracks match attendance, revenue trends, and fan demographics. Example, understanding which matches generate the highest ticket sales and merchandise revenue. Why data visualization is important? Helps team managers, analysts, and IPL franchises make data-driven decisions. Enhances strategy planning, fan engagement, and revenue generation through insights from dashboards. Key aspects of data analytics in IPL. Introduction to data analytics in IPL. IPL franchises rely heavily on data analytics to make strategic decisions in multiple areas. This slide highlights 5 key aspects where analytics plays a crucial role. 1. Player performance analysis. Evaluates batting, bowling, and fielding metrics to assess individual players. Example, batting analytics use metrics like strike rate, average, dot ball percentage. Bowling analytics track economy rate, dot ball efficiency, and wicket-taking ability. Techniques used: data visualization, regression models, clustering. 2. Team performance and match strategy. Helps teams develop winning strategies based on past performances. Pitch and venue analysis determines the best playing 11 for specific conditions. Head-to-head analytics compares team strengths and weaknesses. Techniques used: machine learning, specifically random forest and XGBoost, win probability models. 3. Auction and player selection. Helps franchises make informed bidding decisions during the IPL auction. Identifies undervalued players based on historical data and scouting reports. Uses sentiment analysis and historical auction trends to predict player value. Techniques used: smart bidding algorithms, clustering models, historical auction analysis. For opponent and in-game strategy. Used for matchday decision-making based on opponent analysis. Bowling plans targets batting weaknesses of the opposition. Betting order optimization identifies the best batting lineup against different bowlers. Field placement analysis uses heat maps and predictive models for defensive strategies. Techniques used: Hawkeye data, heat maps, predictive modeling. 5. Fan engagement and business analytics. Tracks social media trends, fan reactions, and business revenue streams. Social media sentiment analysis monitors fan engagement and reactions to teams and players. Revenue and ticket sales analysis tracks match attendance, merchandise sales, and sponsorship impact. Techniques used: NLP or natural language processing, web scraping, demand forecasting. Overall, data analytics transforms IPL strategy across player selection, team performance, in-game tactics, and fan engagement. IPL teams use advanced AI, ML, and predictive models to gain a competitive edge. The next frontier. Real-time analytics and AI-driven decision-making in IPL matches. Use cases. Introduction to machine learning or ML in IPL. Machine learning plays a crucial role in IPL data analytics, providing insights for teams, analysts, and stakeholders. Helps in decision-making for auctions, player selection, match strategies, and financial planning. 1. Distribution of salary brackets of cricketers in the left graph. This graph analyzes salary distribution among IPL players. Highlights which salary ranges are most common and how many players fall within each bracket. Useful for franchises to identify market trends in player salaries. Agents and players to understand salary expectations. Auction strategy to optimize team budgets. 2. Top 10 players by run scored in a season in the right graph. Displays the highest run scorers in a season. Helps in performance benchmarking for future matches. Auction strategy. Teams may bid aggressively for consistent top scorers. Fan engagement and sponsorship. Top performers attract higher endorsements. Overall, these examples demonstrate how ML-driven analytics enhances IPL decision-making. Beyond player salaries and performance, ML is also used for win probability models, injury predictions, and real-time match analysis. Future scope. AI-powered insights for real-time in-game strategies. Introduction to clustering. Clustering is an unsupervised machine learning technique. It groups similar data points based on hidden patterns. Helps in discovering structures in data without requiring labeled data. Applications of clustering. 1. Customer segmentation. Businesses use clustering to group customers based on purchasing behavior. Helps in targeted marketing and personalized recommendations. 2. Image segmentation. Used in computer vision to detect objects in images. Example, face recognition, medical image analysis. 3. Anomaly detection. Identifies fraud or unusual behavior in banking and cybersecurity. Example, detecting fraudulent credit card transactions. 4. Recommendation systems. Group similar movies, products, or music based on user preferences. Example, in Netflix, Spotify, Amazon product recommendations. Relevance to IPL data analytics. Player segmentation. Grouping players based on their batting or bowling styles. Team performance clustering. Identifying similar teams based on performance metrics. Match prediction. Clustering matches based on venue, pitch, and previous outcomes. Fan engagement. Analyzing social media trends and grouping fans by interests. Overall, clustering helps in data-driven decision-making across various industries. In IPL, it plays a vital role in team strategies, auction planning, and fan engagement analytics. Introduction to clustering in IPL analytics. Clustering helps in grouping players based on similar patterns in performance. It allows teams and analysts to identify player roles, strengths, and weaknesses. Key aspects of this analysis. Dataset. Player performances in IPL from 2008 to 2020. Minimum criterion. Players must have played at least 10 innings to be considered. Understanding the scatter plot. X-axis, number of wickets taken. Y-axis, number of matches played. Size of dots represents catches taken by the player. Insights from clustering. 1. High wicket takers. Blue cluster on right. Bowlers with high wickets and more matches. Likely lead pacers or spinners in their teams. 2. All-rounders. Mid-range cluster in orange or pink. Moderate wickets and consistent match presence. Could be bowling all-rounders. 3. Low wicket takers. Left cluster in green or yellow. Either part-time bowlers or players with limited opportunities. Application in IPL strategy. Helps in identifying key bowlers for the auction. Supports game strategy by analyzing bowling impact. Useful for predicting player roles and future performance trends. Overall, clustering enables data-driven decision-making in team selection and match strategy. Provides actionable insights for franchises to enhance performance evaluation. Introduction to player clustering. This analysis helps in categorizing IPL players based on their batting, bowling, and all-round performance. Useful for team selection, auction strategies, and performance optimization. Step-by-step approach. 1. Data preparation. Convert ball-by-ball match data into player-level statistics. Extract key features such as runs scored, wickets taken, strike rates, economy rates, and catches. 2. Clustering implementation. Apply different clustering techniques like K-means, DB-scan, or hierarchical clustering to segment players. Identify patterns in batting, bowling, and combined all-round performance. 3. Interactive UI for exploration. Build a simple interactive dashboard using IP widgets to fine-tune clustering models. Allows for hyperparameter adjustments to refine player classification. Understanding the clusters in scatter plots. Top left plot or purple cluster is batting statistics. Groups players based on runs scored, batting averages, and strike rates. Helps in identifying top batsmen and emerging players. Bottom left plot or orange cluster is bowling statistics. Segments bowlers based on wickets, economy, and consistency. Useful for separating leading pacers or spinners from occasional bowlers. Right plot or green cluster is combined batting and bowling statistics. Highlights all-rounders who contribute both with bat and ball. Critical for strategic team balance and match selections. Key takeaways. Optimizes scouting for IPL auctions and team selections. Enhances data-driven decision-making in player performance evaluation. helps teams identify key strengths and weaknesses across different playing roles. Step 1. Creating the player statistics from the raw data. The first step in clustering IPL players is to extract meaningful insights from the raw match data. The dataset consists of ball-by-ball match records, including details of players, runs, wickets, venues, and outcomes. Exploratory data analysis or EDA steps. 1. Create batting statistics. Aggregate player performance by summing runs scored, strike rate, boundary count, and dismissals. Helps in understanding consistent versus aggressive batsmen. 2. Create bowling statistics. Extract key metrics like wickets taken, economy rate, dot balls, and bowling average. Identifies bowlers based on their effectiveness in different match conditions. 3. Merge data for holistic analysis. Combine batting and bowling stats to assess all-rounders. Integrate match context such as venue, opposition, and match results. 4. Filter players for meaningful insights. Exclude players with insufficient matches to maintain data reliability. Apply a minimum threshold of 10 innings to qualify for clustering. Key takeaways. The structured data transformation allows us to apply ML clustering techniques in later steps. Ensures we capture trends in player performance over multiple IPL seasons. Provides a data-driven foundation for team selection and auction strategies. After performing data pre-processing and filtering, we now have a refined dataset of 336 players. This dataset ensures that we are analyzing consistent and significant performers in the IPL. Key insights from the distribution of matches played. 1. Histogram interpretation. The majority of players have played between 20 to 50 matches. A long tail indicates a few players have played over 100 to 150 matches. 2. Statistical summary. Mean, 48 matches per player. Minimum, 10 matches set as our threshold. Maximum, 195 matches indicating long-term IPL players. Standard deviation, 42 matches, showing high variance in experience levels. Why filtering is important? Ensures data quality by removing players with insufficient data points. Helps in identifying trends and patterns without extreme fluctuations. Provides a robust dataset for further machine learning analysis, especially clustering. Next steps. Now that we have a refined set of 336 players, we will move forward with clustering techniques to categorize them based on performance attributes. Step 2. Apply the clustering algorithms to the player's data. We are using K-means clustering, one of the most popular unsupervised learning techniques for segmentation. The goal is to group players based on similarities in their statistics. How does K-means work? 1. Choose the number of clusters or K. We set K equals 3, meaning players will be divided into 3 distinct groups. 2. Select K random points as initial cluster centroids. 3. Calculate the Euclidean distance of each data point or player to the cluster centers. 4. Assign each player to the nearest cluster. 5. Recalculate cluster centroids based on new assignments. 6. Repeat until centroids stabilize or the maximum iterations are reached. Why did we choose K equals 3? The elbow method shown in the graph helps determine the optimal number of clusters. The graph shows a sharp decline in distortion until K equals 3, after which the decrease slows. This suggests 3 meaningful clusters where further segmentation may not add significant value. Next steps. We will now analyze what these clusters represent, possibly grouping players based on batting, bowling, and all-round performance. Understanding the scatter plot. The x-axis represents strike rate, that is runs scored per 100 balls. The y-axis represents total runs scored by batsmen in the IPL. Each dot represents a batsman, and the clustering helps identify different categories of players. Insights from clustering. 1. Cluster of high-scoring batsmen. These players have scored above 2,000 to 4,000 runs. Their strike rates mostly fall in the 120 to 140 range. This suggests they could be consistent players or anchors, accumulating runs steadily rather than playing aggressively. 2. High strike rate but low runs. Some batsmen have strike rates above 160 to 200 but have scored fewer total runs. This suggests they could be low-order hitters who don't face many balls, finishers who play quick but short innings, players with shorter IPL careers. 3. General trend observed. Players with moderate strike rates 120 to 140 tend to have the most runs. This indicates that high strike rate players may not get long innings or consistent opportunities. Overall, the clustering helps categorize IPL batsmen based on their performance. It provides insights into different batting roles, anchors, aggressive hitters, and finishers. Teams can use this analysis to identify reliable performers and strategic players for different match situations. Key takeaways from clustering and use case conclusion. This study demonstrates how clustering techniques can be applied to cricket data. By tuning hyperparameters, we derived the best clustering model. The primary goal was to explore different types of clustering and extract meaningful insights from player statistics. How the clusters can be used further. Once players are grouped, teams and analysts can use this information in multiple ways. 1. Strategic planning. Coaches can develop specific strategies for different player clusters. Example, using high-scoring batsmen for stability and aggressive hitters for finishing. 2. Team formation. Teams can balance batsmen, bowlers, all-rounders, and fielding specialists while selecting a squad. 3. IPL auctions and player selection. Franchises can analyze where a new player fits in before bidding. Helps in choosing underrated players based on performance trends rather than just reputation. Final thought. Clustering is a powerful analytical tool that can optimize decision-making in cricket. The same approach can be applied to other sports, businesses, or even customer segmentation in marketing. Future of data analytics in IPL. The Indian Premier League or IPL is not just about cricket, it's a tech-driven league. Data analytics is evolving rapidly, shaping how teams, players, and fans experience the game. Key technologies driving the future. 1. Edge computing. Real-time player performance tracking with IoT-enabled sensors in bats and wearables. Instant feedback for coaching decisions, reducing dependence on post-match analysis. Helps teams make on-the-spot strategic changes during matches. 2. Blockchain. Secure and tamper-proof player contracts ensuring transparency. Digital ticketing to prevent fraud and black market sales. Verifiable game statistics, reducing errors and controversies in decision-making. 3. Virtual reality or VR. Immersive match experience for fans using VR-powered technologies. Allows fans to watch games from a player's perspective or enjoy a stadium-like atmosphere from home. Potential for VR-based training sessions for players, enhancing skill development. Overall, the IPL will continue evolving with data and technology, making cricket smarter, fairer, and more engaging. These innovations will redefine player training, fan experience, and overall league operations. Technology has significantly improved the accuracy of umpiring decisions, helping reduce human errors and making the game fairer for players and fans alike. There are 3 key innovations. 1. Automated no-ball detection. AI-powered cameras instantly detect front-foot no-balls, reducing dependency on on-field umpires and ensuring consistency. 2. Enhanced DRS transparency. Advanced ball tracking and predictive analytics provide more reliable decision review system or DRS outcomes. 3. Predictive LBW decisions. AI-driven models help predict LBW decisions more accurately, reducing controversial calls. These improvements not only enhance decision-making but also build trust among players and viewers, ensuring a smoother game experience. Now, let's discuss the role of biomechanics and wearable technology in modern cricket. With advancements in sports science, players and teams are leveraging wearable tech to track and optimize performance, fitness, and recovery. Key areas where wearable technology is making an impact include 1. workload optimization, sensors track movement, speed, and workload to prevent overtraining and injuries. 2. Cardiovascular health, monitoring heart rate and exertion levels helps players maintain peak fitness and avoid exhaustion. 3. Hydration and fatigue management, smart wearables detect dehydration and fatigue levels, ensuring players stay in top condition. 4. Sleep and recovery, sleep tracking devices help in understanding rest patterns and optimizing recovery. The image on the right represents how AI-driven insights from wearables provide real-time health data, allowing for personalized training plans and injury prevention strategies. With these innovations, teams can make data-backed decisions to enhance player performance and longevity. Let's explore how data analytics is transforming cricket betting, especially in the IPL. With the rise of online betting platforms, analytics is playing a key role in enhancing prediction accuracy, user engagement, fraud detection, and market insights. Here are 4 major applications. 1. Predictive analytics for match outcomes. Win probability models use real-time match data such as wickets, partnerships, and run rates to predict results. 2. Real-time odds adjustment. Dynamic AI algorithms analyze each ball's impact and adjust betting odds accordingly to maintain market balance. 3. Fraud detection. AI-powered anomaly detection helps identify suspicious betting patterns, preventing fraudulent activities. 4. Sentiment analysis for market trends. NLP-based tools scan social media, expert predictions, and fan sentiments to track betting trends. The image at the bottom represents popular betting platforms utilizing these technologies. With data-driven insights, betting companies can offer personalized recommendations, fair odds, and secure transactions, making the industry more transparent and engaging. This slide explores how blockchain technology can revolutionize IPL data analytics by enhancing transparency, security, and real-time access to crucial data. We'll focus on 5 key areas: ensuring tamper-proof player statistics, creating unique fan experiences with blockchain-based tokens, combating ticket fraud through smart ticketing, streamlining sponsorship and revenue distribution, and promoting fair bidding in player auctions. As the slide visually depicts, these 5 pillars built on blockchain technology offer a powerful tool to enhance the IPL experience for players, fans, sponsors, and the league itself. To summarize, the IPL is not just a cricket tournament, it's a multi-billion-dollar entertainment industry. Data analytics plays a crucial role in understanding fan engagement, optimizing marketing campaigns, and driving sponsorship deals. By analyzing viewership trends, social media interactions, and audience preferences, franchises can personalize fan experiences and increase revenue. As the image depicts, the IPL has evolved into a data-driven spectacle that goes beyond the sport itself, offering a captivating experience for millions of fans. As the league continues to grow, data analytics will be key to its continued success.